Thank you for joining, guys. This is the Oracle Machine Learning Office Hours. I'm Marco Serancibia. Cheryl Lamonica and Mark Cornick are with me as well. So if you guys have any questions at any time, please don't hesitate to use the Q&A to ask your questions, okay? So today I wanted to touch on a topic that we have been getting a lot of requests for. And as I mentioned before, you know, anytime you guys have questions and have specific things you would like to do, don't hesitate to contact us, okay? So this was inspired by a couple of requests that was asked. And basically the idea was that when you are doing things like REST APIs, right, you want to create an application that's going to call a function, then many times OML4Py REST API is a great solution, right? Because you can create your own open source Python code. You can store it, right? You can store the model object, right? So if you run a model, you can create that object. You can store it in the Oracle OML4Py data store. And then you can store the script that you can use to predict on our OML4Py script repository. So when you do that, you can actually call a REST API and then execute a REST call to that. So what we're going to see today is how to do that. There's one way to do that using an open source algorithm, but also show you a creative way of using an OML model. So how do I do that with an OML model? Because the REST APIs, right, the row apply, table apply, all of those functions actually send and transform automatically for you the data coming in as an OML frame, right, as an Oracle database table. They transform that into and convert that into a local pandas data frame. So if you need to push a lot of data into your function, right, then it might not be advisable, right? So we're going to see how that methodology works, okay? So I'm going to jump into the notebook. Okay, so now I'm at the top here. So what we have here is basically what we're going to do is we're going to score a scikit-learn a Python model, right, using OML4Py. But also, I'm going to play with OML model random forest as well. So what I'm going to do here, first things first, right? So you got to create and build your open source model using scikit-learn, right? So I got to import, you know, let me increase the font size. 1 second. All right, so you can then import, you got to import, you know, OML and pandas, right? And then you're going to import scikit-learn to load iris, right? And the random forest classifier, for example. So we load iris into a local Python memory, right? This is the iris here. Then we have to convert that into the X and the Y, right? And we use the PD data frame, right? So we convert that into pandas data frames. And finally, we can concatenate that iris as an iris DF, right? So this is now a pandas data frame. To build a random forest and using that, I can use something like this. So random forest classifier, I'm going to use 100 estimators, and then I do the RF species.fit with the X and the Y, right, as inputs, these two guys over here. And then we check the importance of the features, right, of the random forest model. So we can run something like that just to see, you know, this is model, right? This model is working. And then what we're going to do here on the top is we're going to store that scikit-learn open source model into our Oracle machine learning for Python data store, right? So the OML data store save, and we see what object we're saving, right? We're storing that object, and we're going to give it a name, right? This is the name we want to give it. And then this is the name of the data store. This is going to be overwrite, right? So, and I can grant access to it to other users, and I give it a description and things like that. And if I check the description of that object, right, and then this is what it comes back with, right? It tells me, okay, yeah, that object is stored there. Right, so now let's contrast that with what happens if you want to build, and this is a random forest. I'll fix this in the text. But I decided to build a random forest model with OML, right? So to build a random forest with OML, basically what I have to do is, as an input, I have to have an Oracle database table, right? So the first step here that I'm doing is I'm deleting, if the model exists in the database with that same name, rf_pred_species, I'm going to delete it, okay? And then what I'm doing is I'm saying, okay, this is Iris OML data frame, right? But I'm doing an OML sync with a table from the Oracle database. So I'm creating a proxy object, right? I'm not pulling data through the wire. So I'm creating a proxy object. And here I'm creating the X and the Y as well, right? In one pass as, again, proxy objects, right? These are still proxy objects and views to the original table, right? All right, so now I'm going to create my random forest. So I do settings, 100 trees, and then the OML RF object, and then I'm going to do a fit. So I do a fit of that X and the Y that I created up top. And then there is the secret sauce, because when you do model_name, every time you use OML models, you're actually writing that model to the database, okay? So when you do that, I mean, if I didn't do this, it will still write the model to the database, but then it's going to get those temporary names that I might not be able to find, or it might be weird. I can rename it afterwards. So if you're building like multiple models, you can just leave it out and then only rename the model when you got the final version you like, right? So that's a possibility. But in this case, what I want to do is I want to just say model name equals. So this model gets created in the database. And then I show the attribute importance, the same thing I did with the scikit-learn, right? And you can see here the attribute name and the attribute importance, and they're similar, reasonable. Now, on the right-hand side, I was using the data store, right, before to store my open source object. But on the Oracle Machine Learning model, you don't need it, right? Because I gave it a name, it's there. So I'm checking it in SQL whether that model exists, right? So I'm checking SQL for the all mining models. And then I passing the model name, and yeah, it shows me there is a model with that name over here, and this is the type, and so the model is there. There's nothing I need to do in addition to that process. Okay. All right. So now I'm going to build the scoring code for both, right? Side by side here, right? So on this one, on the left-hand side, I'm going to have the import pandas, import OML, get my object, right, from the dictionary, from the data store load, right? So I do a data store load and I load my model, right? Because I'm assuming whenever you're sending that function to be evaluated, I need to score, and so I'll bring that model over to the memory, right, the local memory, and then I'm going to prepare the data the same way I did it before. And now I'm going to be running that against this IRIS-DF, right? So when you run it, basically the idea now is that you get the results, right? So the results that I'm asking for is I'm saying, pick up that RF species model that I already had and just predict. And predict on this IRIS-DF, right? So that's a pandas data frame using these columns. And then concatenate that, please, right, with the prediction. So I get down here the example, right? So I have all of those columns, the original columns, plus the species, right, which was the original target, plus the predicted species now, right? That's my predicted target, right? So I see that the model is very, very good. It might, confuse just one, right, or two, but it's a very, very, very good model here. So what happens on the right-hand side? In the right-hand side, I'm using the exact same process, but because it's an OML model, then all I need to do is I need to just create a proxy object for my data, and I pick up my saved model, and this is the way to do it. In OML, every time you want to bring up a previous executed model into OML4Py, you just use the name of the algorithm, right? So this is the random forest algorithm, and then you pass the model name, okay? So what it's doing here is going to say, oh, instead of building a brand new random forest, I'm actually picking up the one that's existing in the database and I'm bringing it into this object here. Okay, so now I can use that guy to predict. So I run this guy, I will predict, and all I need to predict is, well, my original proxy object, right? So my table. Now I'm passing this as a table here. So I don't need the species as target, for example, right? Because that's not necessary for my as an input, right? So I can drop that. But OML has also an advanced function here, which allows me to, every time I'm predicting, because every time you predict, users want to have a supplemental column. They want to have the customer ID. You know, you always need something, right, attached to that prediction. That prediction by itself is not really useful, right? If you just get the number out, you really need something together with it to show. So we created this supplemental columns function where you can just pass what are the columns you would like to see with that. And in my case, I'm just passing the entire thing. I'm saying, you know, just send me all columns, just like we did on the left, right, with the open source. So now we get the exact same output. We got all the columns and the species plus the prediction, right? So there you go. So and then you expect the same thing that's going to happen. You're going to get, yeah, like, you know, one confusion here and there, right? That's the same thing. All right, so let's check the options to create the scoring endpoints, right? So with OML4Py, basically when you, after you build those functions, right? So we have two options, right? So what happens with OML4Py normally is you would then get, if you pass the OML data frame in OML4Py, you'll get the entire table, right? You get an entire table, and in the REST API, you do select star from as an input. And then what the database does is it converts that into a pandas data frame and then pushes that into your function, right? So your function in the left-hand side, when we use REST APIs and we use table apply and group apply and row apply, you're going to receive as that, you're going to get a pandas data frame when you go and access this, right? So because of that, this dat here, right, is a pandas data frame already. So now all I need to do in my function is bring and load that data store, right, with the random forest model that I had with scikit-learn, bring it over, and then go and predict against that, right? This specifically that function there, that data set, right? So remember, this is when I call this function using OML4Py table apply, I'm going to be actually pushing that as a table, right? As an Oracle database table, but that is going to be converted into a pandas data frame. So I'm receiving a pandas data frame right here, right? Now for the right-hand side, it's a little bit different, right? Because, I mean, you could give me a pandas data frame, and then if I receive that pandas data frame, because I'm using an OML model, my input data is actually has to be a table, an Oracle database table. So I could do an OML push, right? And push the data back to a temporary database table, and then I would be able to run my model. But that might not make a lot of sense, right? If your table is big, you're going to be pushing, the database is going to push the data to you, right, to your function as data as a pandas data frame, and then you're going to be uploading it again and into a database at a temporary table to use it, right? So that might not make a lot of sense. So what we figured out, working with Sherry a lot on this, we figured out that there is a very interesting thing that you can do, which is I can actually get into my function only a string. So say that instead of giving the function the table as a whole, I give the function the table name that I want to use. So that is interesting because now the entire table apply, right, it's going to just convert that single row, which only contains one string, into a local pandas data frame. And with a single row here like that, I can extract the value of that single row. And now I can just do a sync, right? So I can now create my proxy object to the table, which the name is this one, right? And now I can do my random forest. And remember, I don't need to pull that from a data store, right? If it's already in database. So all I need to do is I'm just point that name, model name equals, and at that point, I'm pulling that name in. So that model that is an Oracle Machine Learning random forest is here, and I'll do a predict. And now this that here is actually the proxy object to a table whose name I received that, right? I received over here the name. So when I get that name, then I can do just that. So predict that, and the supplemental columns, I'll get them all, okay? So what happens then? What happens then is I will, on the left-hand side, I will store the scikit-learn random forest script, right? So I'm storing the random forest script called predict pred rf species, right? With that name, and I'm giving it a description. On the right-hand side, I'm storing my machine learning random forest script, okay? And then I give it a name as well. So let's check the functionality of those guys. When I send then an OML data frame as input, right, into my my local random forest scikit-learn, I test it like this, right? So I'll do iris for scoring, right? So I'm doing OML sync first, and then I'm gonna get the script load, right? So I'm gonna load that script, the predicted random forest species, and what I'm passing it is I'm passing a local iris. Remember, this guy needs to have that function, the function that's coming in is actually just the data, but it's a local format, right? It's a pandas data frame. So I'm passing a pandas data frame to the function, and I can see that it works. So let's test using row apply. Using row apply, what I can do is I can say row apply, this is the name of the function, right? This is the script that I just loaded. So that's the script. And then I say, you know, rows 50. So use 50 rows at a time and go into parallel mode. So that means a database is going to slice the data set in pieces of 50 records, and then it's going to push it to that function, right? 50 records at a time. And because I'm giving it a parallel, if I have the parallelism available to me, I'm going to be able to run that in parallel, right? Same thing again. So the result is here, right? You get the result you were looking for. Then the other function is table apply. So table apply takes the entire table and pushes it to the function. So that's all I'm doing here. Table apply, get my input OML DF again, and that's my prediction, my function. And that's all I get, right? So I get all the entire function now. Now see that this is the OML data frame, right? So when you're using table apply from here, this is no longer a pandas data frame. This is an OML data frame, but the function table apply is going to convert this guy into a pandas data frame and use into that function, right? And same thing with group apply. The only difference here is I'm using an index. So I'm saying, you know what? When you're doing the predictions, please split the predictions into buckets of species and predict one species at a time. So it's slicing that into the 3 different species, and then is using parallelism again, right? So I'm sending it a parallel here. So I can do that. So for example, I'm checking the predictions for the group versicolor here, and that's the result, right? So for the versicolor, you know, there you go. I got a 1 mistake there, right? So all of that is using, again, as an input, my data frame as a table, right? So that's my Oracle database table that the function is converting into a pandas data frame. Now, for a single string, right, as the name of that table. So how do we do that? Well, so this was the trick. So we created here a pandas data frame with a single column called table name with a single row called iris, right? I don't think I don't even need to that name. I mean, this can be anything, but within the single row that is iris, right? And when I do that, then I send that into my function that is doing the OML one. And this guy is taking that function as you see as a pandas data frame, right? And it takes that in and then it processes it and it works. So on the right-hand side, for table apply, all I need to do is I need to take that single row pandas data frame, right? And then push it to as if it was my Oracle database table, because remember, table apply, row apply, group apply, index apply, these guys take an Oracle database table as input. But my table now is just a single row with a single value in it. And my function is smart enough to be able to run it. So I take that function, that single string, and then I pass it to my my function that wants to score it, and that's it. So I get my my output exactly the way that I need it. Okay. So if I wanted to do that row apply or group apply, it doesn't make sense, right? Because row apply, I have only one row. That's the name of the table, right? So it will work. You know, it works if you give it a rows equals 1, right? But there's only one row because the input now is just the name of that table. And group apply, there's no way to do any group apply because there's only one single string in that name and there's nothing we want to use there, right? So to finish this up, what I wanted to show you guys is testing that same prediction using REST API, right? So if you go here in Postman as an example, right? So I'm going to get a user token, right, on my server. And you guys can see more details on all the OML services that demos that we have done. But now I'll do a score of a table, right, using an open source Python random forest, right? So I just need to point to that script. Remember that when you save a script in the Oracle Machine Learning for Python script repository in the autonomous database, it's available right here as an API immediately, right? So I have a table apply and I run a prediction RF species. Now, how do I tell it the data that I want to use as input? So this is the way you do input, select star from iris. That's my input. That's all I'm sending. I'm sending that, give me that input. These are the parameters, and that's the name of the function I'm going to use, okay? So I'm going to do send, and then what the database is going to do is database is going to say, okay, let me take your iris, right? All the data that is coming from that query, I'm going to push it to your function, convert it into a normal pandas data frame, and here you go. That's the result, right? I can visualize a result like this, right? So, and then you have the scoring exactly what you were asking for, right? Exactly the results that you were asking. Now, of course, this might be too much data, so you have to be very careful when you do these kinds of things, right? You don't want to send 1 million records like this, and then you're going to get everything back in your REST call, right? Now, how do we do that for the OML then? So pay attention to this, right? You got select star from iris. So on our version, on the OML, what we're doing is now we're doing select iris as data underscore string from dual, okay? You can do that, you know, you can call it anything, right? What the database now is going to do, and I did not need the rows here, right? That's for row apply, so I don't need this guy here. But what you can do here now is, if you imagine that query only has one single string, right, with that name, and that table now is being passed to our function. Remember that our function is expecting a single line, a single character that's going to convert into a table and do an OML sync on it, right? So then you can send that, and then we're going to get, and the idea is you're going to get the same output, right? So we got the same exact results. They should not be the same exact ones, right? But it's a little bit different than the other one, right? Because OML has a prediction output. In the scikit-learn, you get something called predicted species, right? So that's just a little bit different, but the idea is that, right? So, and with this thing, you get then that kind of output immediately available for you. Okay. All right, so I think I used the entire 30 minutes that I had originally. Mark, Sherry, any questions left?
No, it looks like we've covered them all. I mean, the one question that came up had to do with, where was the database connection made? And so Sherry had responded that, in Autonomous Database, of course, by virtue of loading the library for OML, the connection is established after you run that paragraph. It's only in the on-premises version, like we have for OML for R, where you need to establish the connection explicitly.
Oh, correct. Yes, exactly.
And there was a second question about an OML developer user profile issue, but it seems like that will be taken offline. One question, Marcus, maybe a clarification is, so when we have a model that's created using OML for Pi, and if you don't assign the name to it, what happens to that model when you disconnect from the database?
Oh, yeah, that's an excellent question, Mark. Thank you. So basically, guys, when I was showing you that when I was building the model, right, and I was building and writing the model over here with giving it a name. Let me just get to the right place right here, right? When I give it the name, the thing is that model now gets stored in the database and it's there, right, for any other people that are authorized to access it, to use it as well. But if you don't give it a model name, then this model is temporary, right? So it has a temporary name. You could find it if you try to figure it out where it is, but the problem is when you disconnect from the database, the model gets deleted, right? So everything gets wiped out. So that's why I was saying probably useful only not to give it a name if you're testing several versions of it on the same session, right? And then you want to just keep the one good, then you can give it a model name. That's for sure. Yeah, thank you for the question, Mark.
Sure. And I mean, one other thing is even if you forgot to give it a name and after the fact, you can assign the name using that sort of variable of the object itself. So you can assign the name even afterwards, and that will cause it to not be reclaimed at the end of the session.
Yeah, correct. Perfect. Yeah, that's what I was mentioning as well, that you once you have the model you like, then you can use a .name equals, and then that model gets stored. Yeah. Excellent.
I think that's it for questions then.
All right. Okay, guys. So thank you very much, Mark. Thank you, Sherry. Thank you, guys, and talk to you guys next week.